Welcome back, everyone. In case we haven't met, my name is Andi, and today I'm here with Captain Chris Hearn, director of the Marine Institute's own Center for Marine Simulation, here to talk with us about ice management and maneuvering and what the CMS does in that field. Thanks so much for being here today, Chris.
Glad to be here, Andy.
So, to a lot of people, not necessarily in the know, such as myself, uh, and I know my parents listening out there too, ice management might mean just dealing with ice around their neighborhoods or their cars or on the roads in the winter. So, what exactly does ice management mean to you, though, within the CMS perspective?
That's a really good question. It's a very complicated task, to be honest. Complicated in its delivery, straightforward in what it achieves to do. So,
Mm.
when you're talking about ice management in the context of the offshore oil and gas industry, so let's start there. Offshore energy.
Ooh.
In a place like Newfoundland, we are exposed to two types of ice. We get glacial ice calving off the west coast of Greenland,
Yeah.
and then we get pack ice that flushes out of the eastern Arctic and is carried down by the Labrador Current.
Mhm.
So we have both types, and they occur quite often at the same time or very soon. You know, you will see pack ice, and then you'll see the icebergs that everybody loves to come and see.
Mhm.
Both are a threat to shipping. And in terms of pack ice, the type of ice you'd see in the Arctic, this sort of thing, it can range from first year to old or multi-year ice, which is very hard. Consistency of concrete, very dangerous to ships.
Wow. Okay.
You know, you get your ship stuck in it, you can become beset, which is essentially ice that's got you under pressure, which can possibly damage your hull
Oh.
or tear off your rudder or your propeller,
Mhm.
leaving some damage. It's a really serious situation. So we teach people how to navigate in ice. That's the first thing. But when you get into ice management, traditionally in the Newfoundland context, it focuses around operations related to preventing icebergs from incursion or possible threat to offshore drilling assets, offshore drilling or production.
Okay.
So in the Newfoundland offshore industry, we have both fixed assets
Mhm.
like Hibernia or Hebron that are sitting on the sea floor. They're a gravity-based structure.
Okay.
And then you have the moored systems, the Sea Rose and the Terra Nova. These are essentially ships with refineries on board, and they're connected to their fields via a riser and a turret system. Ice has always been identified as a threatening issue here.
Sure.
And, think back to the Titanic, ice rocks, right?
Yeah.
So it's a long history. When you're talking about controlling ice or ice management, what you're trying to do is prevent these icebergs from interrupting the operation that's going on, a drilling operation or production operation.
Mhm.
And that's where it gets complicated because there's all kinds of methodologies that actually occur to do this.
Sure.
It is the focus of an enormous amount of effort on behalf of the regulators here, but also the operators themselves. They take this stuff very, very seriously.
Sure.
And it's all predicated around this idea of what's called a T time. And the T time is essentially a small calculation that evaluates the threat to the asset based on the time an iceberg enters a zone,
Mhm.
the time to disconnect or stop an operation, and then the time, of course, to secure and then move the rig or the platform. So
Mm.
that time, that T time, is very important to when they identify a piece of ice and say, this could impact us. That starts a clock running in terms of what they're going to do.
Hmm.
For obviously a fixed asset like Hibernia or Hebron, you can't move those.
Right.
They're there.
Mhm.
They're there on the seafloor. Interestingly enough, when Hibernia was built, it was designed to withstand an impact from an iceberg that could drift onto the field. It's over-engineered and designed.
Okay.
Nobody wants to ever see that happen, of course.
Right.
Hebron is a little bit lighter, but they figure where it's to, they don't see the type of ice that they might encounter for Hibernia. But for the floating assets, for Terra Nova, and particularly for Sea Rose on the White Rose field, they seem to be in the path quite often of icebergs that drift onto their field. Now, a lot of these don't present an issue. But when something does present an issue, they have to figure out, A, is that iceberg really a threat? B, what kind of a threat is it?
Mhm.
C, do we have to stop production? D, do we have to disconnect?
Mm.
That's a kind of a service. So to do the ice management is a combination of tracking the iceberg,
Mhm.
figuring out what's going to do, modeling that possible trajectory and what's going to happen.
Mhm.
And then comes the tactical side, where the supply vessels, the anchor handlers, the supply boats that are there on duty, are tasked to try and prevent this piece of ice from doing something. So
Mm,
they look at a combination of features. They may deploy nets to try and tow,
mm,
either by themselves. One supply will go out and deploy a net and a line system around the iceberg
mhm,
and try and tow it, or two of them will come along with a net between them, try
mhm,
and catch the iceberg. Your towing is in as much. When I say towing, the small iceberg, yes, but big icebergs, no.
mm,
You're more kind of just deflecting it to
sure.
get it to move, because icebergs move with current.
Right.
And so you're just trying to nudge it on its trajectory so it's drifting not this way, but a little bit to the other side.
Right.
So that's really what the focus is for a lot of it. But I'm underselling like how much evaluation and tracking and energy goes into actually predicting this. Like enormous amount of work takes place in the offices all around St. John's. The aerial reconnaissance, the satellite reconnaissance,
Mm,
and the methodologies for predicting iceberg movement, even when they're being towed. A lot of work down the university in the faculty of engineering like is focused on that. So it's a big deal. So easy concept to think about. Managing ice, don't want it to drift in where we're doing some stuff.
mhm.
Complicated in the work that goes into actually trying that.
Wow. Okay. That was really insightful. Thank you so much. So now that we have that background and like understanding of more of what ice management is and kind of looks like, what exactly does CMS have to do with any of that here?
So we do a lot of things in our center. CMS, of course, is primarily a simulation training facility. But our training is at that very high level, that professional, continued professional development type applications that are beyond the regulatory side of things. And our equipment is designed to replicate realistic operating conditions. Our bridges move, they're sitting on, big motion bases, and they look and feel like the vessels that are actually in operation.
Okay.
So when you're learning how to, you think about, I'm going to go lasso that iceberg. It sounds easy, but it's not as easy when you're actually trying to do it. First of all,
Sure.
approaching an iceberg is a very hazardous occurrence. You
Mhm.
don't know what it looks like underneath the surface. You don't know how far protrudes out its structure.
Mhm.
And then, of course, finding it. You can imagine that quite often in Newfoundland, because of the location of the Grand Banks and the weather, dense bog can sometimes make it very challenging.
Oh.
So you have to approach very slowly. And then the deployment of the line and the netting system to kind of lasso the iceberg and then connecting it up and taking it under tow.
Mhm.
So some of our simulation equipment from a bridge perspective, from the people who are actually doing this,
Mhm.
is what we would provide. So they will come in
Gotcha.
and learn some of the features and the challenges and some of the tricks that you would actually do to be part of
Mhm.
that. And then you can scale up beyond the training. Is that a lot of the work we do for industry also focuses on evaluation of planning or a risk assessment or a rehearsal for an operation. So companies will come in and use our simulators in real time to look at, well, here's our plan. Now we're actually going to go down. We're
Mhm.
going to bring in the people who are going to be on those vessels. We're going to organize the entire operation and we're going to let it play out. And we're going to
Mhm.
change the weather or we're going to change some little variable and let's see what actually happens. Just to,
Cool.
to ground truth and really to look for the flaws in the plan.
Mm.
And in an ice management context, we did one of these projects for a large undertaking that was going on in the Sakhalin Sea over in the far east of Russia.
Oh, wow.
And there was a company involved in that operation. They were doing part of the ice management. And what they wanted to do was evaluate some of their procedures for minimizing the tea time or looking at what happens if they've got only so many vessels to do the operation with and they're tasked all over the place. What is the time to get back to the actual vessel or the drill
Mm.
ship that they actually need to do some work around? Because there's another aspect to ice management that I didn't speak about beyond towing icebergs, because that's the most present one that everybody thinks about,
Mm.
is also get pack ice in around a drilling platform.
Mm.
You don't want pack ice putting pressure on the hull or around the rig itself.
Sure.
There's two reasons for that. Obviously, the one is that you don't want it damaging the sponsons or the hull of the drill rig itself. Or if it's a fixed platform, you don't want it kind of crushing it.
Mm.
But also, pack ice moves in response to a lot of wind.
Oh.
It's wind driven,
Mhm.
and sometimes it's also sea driven. But all that has a subtle effect, a global load on the hull. So it wants to push the structure, and you'll push itself, if the rig is here and you're drilling here and all this ice starts to push you, you'll move so far and you'll break the drill strings essentially. And you don't want anything like that to happen. So part of ice management would be relieving pressure around the hull. So the ice breaking supply vessels will circle around and continue to break up the ice into smaller pieces. So they came to trial different scenarios of all that. So
Mm,
that's a short window into ice management. Of course, from a training side outside of ice management strictly, our center has been doing polar and ice navigation training for a very long time, close to 30 years. We're one of the leaders in that type of work, and people come here. Last week, we had a group from Japan. They came
wow.
here to get some ice navigation training, and that's a big part of what we do as well.
Wow, okay, that's awesome, thank you so much.
Yeah, stuff that goes on in the Marine Institute, huh?
Yeah, and I'm very like, I am and I'm not surprised about, like, how far-reaching some of the work that just, like, at the Marine Institute can be. 'Cause, like, you're mentioning, like, things out over by Russia and then people from Japan coming by, and so it's like, how does, like, that word of mouth or does it, like is it a word of mouth thing? Like, how does, like, the knowledge of what we offer here in CMS get around?
Me?
Okay. Okay.
No. It is a lot of it is word of mouth. A lot of it is, the marketing that we can actually do,
Mm,
and it's also speaks to the quality of our product.
mm,
We're very good at what we do. We spend a lot of time and energy making it better.
mhm,
Every time somebody comes through the door inside the shop, inside CMS, we take great care to get feedback on what we're doing. It's
mhm,
part of our quality system, but we take that seriously and we'll review that normally every year. We'll sit back and we'll look at the comments or the what people say and what they'd like to see improved. Obviously, we have great stock with our suppliers who provide the simulation equipment for us. And another benefit is that we are technically proficient. We have really good people and we have a
mm,
technical group inside. So we can often work with our vendors to try and make changes to what their systems have that we're using. And sometimes we can't. So what we can control is how we use the equipment.
sure.
And we've become very proficient at where there are little gaps or shortfalls in the system's capacity to replicate realistic condition.
Mm,
What we can do and what the guys are really good at, the instructors, is finding ways to kind of that you don't see that. There's a lot of work goes on in the background.
sure.
So that's a lot to say that this manifests itself in people coming to do the work with us.
Mm,
In the country, in Canada, we took the lead. Well, we didn't take it. We were asked to lead part of the initiative that saw the training requirements for ships operating in ice under the Polar Code,
mm,
which is the operating legislation that came from the IMO that covers over ships operating in polar waters, both Arctic and Antarctic.
mhm,
So that was a recognition of our expertise, that we
mhm,
had the bandwidth and the experience to help guide
mm,
how those courses should be developed and what the standards for competency should be.
mm,
And, that carries weight.
right.
We're well known because we've been at it for so long.
Sure.
And we were at it long before anybody else was doing it, like close to 30 years. We were doing it before it was a regulatory requirement. It was one of the main things, interestingly enough, from a history lesson. The CMS was first thought of and conceived of, and shortly after its design and its build,
Mm,
polar navigation and operations in ice was one of the main identified things that the center was tasked to pursue. That was
mm.
way back to the 90s. So it's been going on. It's a mature product for us.
Wow, that's really impressive. Okay, so I was actually going to ask you about how long that we've been at this for, but then tangentially to that, you're mentioning the instructors that we have leading these courses. Like, what exactly like goes like? How do you become qualified to even do that?
Yeah, so there are people who are formerly captains,
Okay.
ships operating in ice.
Mhm.
Our lead instructor, Captain McNeil, spent a very long time in the Coast Guard as the commanding officer of the Louis Saint Laurent, which is Canada's premier icebreaker,
Mhm.
and he's been involved in the training since day one.
Mm.
And
Mm.
he's supported by Captain Corrine, who spent a lot of time in the Arctic as well, and Captain Finder. And beyond those guys who've got that experience operating in ice, we have the other part of our instructional staff who are really good with the simulators and create the exercises and do all the behind the curtain work
Mm.
for the simulation side. Because the training is two parts.
Mm.
And this also extends to waste management, so I'll come back to that one. The the regulatory side of navigation and ice training has an introductory phase, which is very heavy on being able to identify and use resources to help you navigate in ice.
Mm.
Ice types and formation and the physics of ice and
Mm.
how ships operate in ice, these sorts of things. Then you have to go away if you were a candidate, if Andi was doing this.
Mhm.
Then you would have to gather, a requisite amount of time in ice on a ship,
Mhm.
and then you would have to come back, and then you would do the advanced level, which is more maneuvering. It's much more tactical,
Mhm.
and learning how to do different types of operations with your ship on ice.
Mm.
To waste management, which doesn't have a formalized training process. It has industry best standards. So
Mm.
when we're involved in these sorts of things, it's more to how the industry group that's with us, how they do their operation. That's how we replicate that. And the guys are really good. They're conversant in both ways. So
Mhm.
that's a little bit of a roundabout answer of saying, like, how do you get good at this stuff? You're good because you've got the experience in the background. You're interested in the delivery of it, but also you spend the time. The guys spend a lot of time looking at what's going on in industry. We're engaged in parts of working groups that are dealing with training
Mm.
for operations in ice. And it's just something that, it's part of the practice inside the center. So
Sure.
it's a combination of multiple things.
Okay. Thank you. Like, what goes into actually creating the simulator and the models that you actually do?
That's the black magic.
Okay.
Yeah, so the simulators, of course, like, we're dependent on our vendors' technology, but modeling of ice is a very difficult thing.
Sure.
It is computationally demanding on the systems as well.
Yeah.
So for many years, ice, in terms of simulated ice, um, was more, I don't want to make it sound like very simplistic, but almost like coloring the water white, putting in some visual features,
Mm.
and then, you would allow a ship to sail into it. We go a little bit further in that because our simulators are motion based. We wanted to put in features that would actually feel like the ship would shake and
Mm.
shudder. And then when you were backing and going ahead back and forth on ice and that sort of thing. And we got, that was fine for the day. But as more ships started into ice and training became more regulated, then there became a demand to say, listen, this needs to be better. It needs to be more realistic.
Mm.
We had actually been part of a project. We led this initiative that was focused on station keeping, like using a dynamic positioning system to hold a ship or drilling platform steady in a fixed position,
Mhm.
and to look at how that technology would be able to identify and then resist ice loading on a hull.
Mm.
One of the byproducts of that, of course, was we gathered a lot of full-scale data from actual sea trials and worked closely with the NRC, who were producing, ice sheets down in their ice tank. And the aim here was to improve the visual and the simulated effort, because there's a trade-off. You can create ice, but when you have a hull or a structure in the ice,
Mm.
the interaction between that structure and the ice can become very demanding, like in terms of the
Mm.
physics and the fracturing of the ice and
Mm.
how
Mm.
ice falls and it folds and it rolls over and it starts to mix with other ice. So you can imagine the physics engine that's generating all that needs to be
Mhm.
very powerful,
Yeah.
because you're doing it in real time and you're not doing it on a desktop application. There are
Sure.
lots of really good modeling software, that you use to model ice interaction, but
Mhm.
doing it full scale on a simulator is a whole different matter.
Sure.
And also visually having it represent that.
Mhm.
So there's a kind of a middle ground there between really high definition visual imagery of ice, which is actually very important,
Sure.
and the underlying physics of the ice acting like real ice will.
Mhm.
And when you get into really heavy old multi-year ice that's got snow on it and these sorts of things, the friction and the rolling and the consistency and the weight and the all that all the stuff,
Hmm.
yeah, you can bog down the simulator. It'll start to slow in a little bit. And and we're not at that level. We know the tricks to get around that.
Sure.
But I'm trying to paint a picture of just how complicated it actually is to model ice. It's been the
Sure.
focus of a lot of people for some while. It's getting more so because now the simulation companies that do this
Mm.
are looking at what the gaming industry is doing.
Oh.
So the gaming industry is really good at its visuals.
Oh, yeah.
I don't need to tell you. I'm sure you've seen those kinds of things before. And so the simulators kind of say the big professional simulation companies are saying, well, we'd like a little bit of that.
Right.
And so they're slowly but surely the group that we work with are slowly but surely putting some of those elements in.
Mm.
We're driving some of that. It's based on our expertise and our feedback, and also from our past exposure and experience with the big research project. We were providing them better detail about what this should actually do. The problem there, of course, is just trying to find what that middle ground is between ice that acts like real ice will, beyond
Mm.
just first year ice, second year ice. We're talking about much more complicated,
Mm.
and visually what that looks like. There's a give and take between both.
Sure.
And so for us, when we're down on the bridges, down on the simulators, we're doing a bit of both. Like we're trying to find that middle ground. And, when you're in ice and you're moving through and you encounter ridged or ice under pressure, the simulator will respond. The ship will rise up in its bow or it'll fall to one side and these
Mhm.
sorts of things. And then we have other little tricks that we use too. Well, so it's a combination of a lot of stuff.
Wow. That's I mean, I'm not surprised to hear any of that at all just because, like, even, like, with the level that I'm of modeling that I'm doing, it's like, "Okay, this model takes a couple of minutes to run. That's a big model." But this is totally in a whole different level, combining so many different things, and so that's really fascinating. Um, one thing that I'm curious about, since we are based at the Marine Institute with CMS and all that fun stuff, um, do you have students getting involved with, like, any, like, operations of that at all?
We're certainly open to it. The
Mhm.
short answer is no, not directly. We've
Gotcha.
had work term students as part of projects in past, definitely.
Mm.
But in terms of the student population here in the institute, in the nautical science program, so maybe near the end of their program in the fourth year, some of the cadets will come down through, and sometimes we can expose them to some of those as part of
Hmm.
their training scope. They're under, they have a very regimented process, and there's a lot of planning goes into that. But in terms of some of the work that we could do or we would do, it really depends on what we're doing. So some of the companies that come in, they're in under like non-disclosure agreements, and
Sure.
they don't want anybody
Yeah.
doing something with the information that they're generating. And some of them are not. Like we've had, as I said, some work-term students in the past who helped us out with some of the projects, some of the recording and writing of the not proposals, but the reports that
Mm.
come out of it afterward. So it's really a fine line of trying to figure out where the best place for people to come in is. And we're certainly open to it. We've always been. It's
Mhm.
just that the reality is sometimes we can't.
Sure. Yeah, I'm still stuck on, like, the kind of, like, video game kind of, like, aspect with the graphics coming in. That's I don't know. I wouldn't call myself an avid gamer, but
We're getting there. Like we're trying to future proof
yeah.
ourselves against some of this stuff because there's all kinds of catchphrases about like how technology continues to evolve and you're
Mhm.
you're never ahead of it. You're always trying to catch up.
Yeah.
There's law and these sorts of things about how technology evolves quickly and exponentially.
Mhm.
So, we, as much as I'd like to, we don't have the bottomless budget that just says, oh, we got to
Sure.
do everything. Our equipment is very advanced and it's very unique.
Mhm.
But we're always trying to look ahead to where we should be heading towards. And when we're talking to our vendors, we're talking about these sorts of things, what you should be looking for, what you should be doing.
Mhm.
Um, the gaming thing is really interesting in that we're seeing now the simulation vendor like who we use, Kongsberg, they're really serious about bringing in some of those gaming visual engines, the Unreal Engine and these sorts of
Mhm,
things
mhm.
with much higher definition graphics
Sure.
to layer over their really powerful physics engines.
Mhm.
And to future-proof ourselves against that, we've invested in, like, for the big bridge for the projection system, a laser-based 4K projection system,
Ooh, okay.
because we want to be able to paint the picture that that technology is supposed to be able to deliver to us in the next, I don't know, 2 to 3 years.
Sure, yeah.
Because our screens are either LCD or they are a great big projection system.
Right.
And we want to be able to reflect as realistically as possible the conditions that people are working in. So that gaming engine initiative, that's broad across all the simulation vendors. One vendor actually crossed over from the gaming industry. They saw an opportunity, they wanted to get in. They saw
Sure.
it's like Coke or Pepsi or like the big companies are up here.
Oh,
They saw an opportunity to focus on some very niche applications, which is good for them, right?
sure.
And so they came purely out of gaming, and they've got some really nice looking stuff, I must say. And
Mhm.
I'm sure that, like, the companies here in the local ecosystem, the maritime ecosystem, like Virtual Marine, are probably evaluating the same things, like how to make the visual look more realistic, because you want
Right.
people to believe they are where they are.
Yeah. It's really funny to me just, like, seeing these different worlds that I didn't think were that related to each other, being able, like, to intersect like that, and so that's really fun. Um, let's see. One thing, uh, like, are there other places in the world that do similar things, like, with these bridge simulators that we're
Oh yeah.
using in
Oh,
CMS?
yes.
Okay.
Across the country there are. None at our level, though. Maritime training in Canada is essentially spread out across the Canadian Association of Maritime Training Institutions, CAMT.
Oh,
Those are the main training facility,
okay.
education and training kind of thing. And
Gotcha.
they stretch across the country.
Mhm.
Um, we're a little bit different.
Mhm.
Well, not a little bit. We're a lot different in a lot of applications, but our simulation capacity goes beyond just purely regulatory training. By regulatory training, I mean Transport Canada has very specific requirements for competency and how to assess that competency for people who are going through a certification system to become a captain or a chief engineer.
Mhm.
And the simulators that provide that service do very specific things. They're
Mm.
required to. And so we're beyond that. Then we don't just do regulatory, we also do industry best practices. And the companies are coming in, and the industry that we're dealing with, the maritime and the offshore,
Mhm.
they want much more involved and much more complicated and complex systems that replicate not only just a training focus, but an operational focus.
Gotcha.
So we're fairly unique in the country and probably on this side of the Atlantic Ocean, to be honest,
Wow.
in that role.
Mhm.
We're one of the very few that are at our level,
Oh, wow.
both in terms of the scope of the equipment, but also there's another thing to be said about the technical aspect. We have really good technical people.
Mm.
We build the ship models in the areas ourselves. We do all that. So
Oh,
if Andy was to come in and say, like, I'm carrying out some sort of a fishery survey from the Labrador coast all the way down to Baltimore,
yeah.
and here's my ship, and here's the type of things I'm going to be doing with it, then we can build that ship. I mean, numerically model it, and then we can put it into one of our simulators, and then Andy can come down, go onto the bridge, and that's
Whoa,
our ship.
that's crazy.
So, yeah, that's a good resource to have.
Wow, that's amazing. Okay, that's super cool. So, like, you mentioned a lot about, um, collaborations with, like, offshore, like, energy and that sort of thing. Do you ever get people from, like, the fishing industry that ever come in?
We did a really interesting project several years ago. We led the technical side. I shouldn't make it out like it was just us. It was a very large initiative to look at stability,
Mm,
stability for fishing vessels.
mhm.
Big issue in the small vessel fleet.
Oh,
A
sure.
lot of accidents there. So we took part in that, and our aim was to get together a working group and create a simulator that would visually help people understand concepts within impact and dynamic stability and what was
Hmm,
going on. It was part of a big learning program. It was very interesting. It was very good.
hmm.
Beyond that, from the fishery side, we've had people from the larger fleet, the factory freezer trawlers, have come in for
Mm.
some training in ice,
Mm.
operations in ice. I think that would be reflective of like the shrimp industry where they're fishing too.
Oh, sure.
We do have the capability of being able to represent trawlers and the controls of trawlers and building models for these types of vessels in the fishery. That's not a problem at all. We can
Mm.
certainly do that. Very specialized training for them, how to deploy the gear and recover the gear under different conditions. We can model all that.
Mm.
Not so specific to fishing, but very parallel, or maybe a little bit of a corollary there to it,
Mm.
is that we were approached about taking part in a study to look at how to deal with whale interaction with fishing operations.
Ooh, okay.
Yeah, it was a bit of a unique ask,
Mm.
and it was kind of there was twofold thing going on there. Like what they were wondering about was one of the local technology vendors here, Rudder, that produces probably the best ice radar and radar technology for detecting things.
Mhm.
They were in some sort of discussion back and forth with a research group out in Alaska
Oh.
that were looking at like they have a problem when they're recovering gear for like orcas
Mm.
getting in around the gear because they're trying to get at the herring or the fish or whatever else.
Yeah.
I think there was another project very similar to going on in here in the institute. And as a matter of fact, it was the flume tank who reached out to us and said, like, these
Yeah.
people are asking about, what's possible in that. So we actually looked at modeling a whale, which was interesting for
Ooh.
us. At the miracle model of a whale. We build ships and we build assets, but whale is a whole other thing. So we got it to a functional state. But if you ever saw the documentary, how they made Jaws, it was always a running gag that the Jaws thing didn't work very well. And
Oh.
they would drag it around, and some days the shark would work, and some days the shark wouldn't work.
Mhm.
And there was a little bit of that with the whale. Like we didn't have high in American model whale. So we did our best, and ultimately that project didn't go all the way through to a point where we would start to do something. But it was a bit of fun for us to actually
Yeah.
trial that a little bit. So this whale would be lurking while you're in fog, and how you would detect the whale when you were shooting away gear or recovering gear. So
Wow.
those are a couple little anecdotes in terms of our exposure to the fishery anyway.
Awesome. There's something so amusing about the concept of numerically modeling a whale.
Yeah.
It makes me very happy.
Well, I'm glad it made you happy.
Yeah.
Our naval architect wasn't very happy about it.
So, like, who are actually the people that are, like, in the behind the scenes with, like, the actual modeling that, like, for instance, like, would have been modeling the whale? Like, you're mentioning the naval
Yeah.
architect?
Yeah, so our naval architect, Elias Sadanoff, was a graduate of the naval architecture program here in our institute. So
Mm.
he's our numerical modeler. He's the guy that builds our ships and our offshore assets, like if it's structures or
Mm.
anything that we have to inject that's a physical asset. And then we have another guy, Chris Connolly, who was our GIS, our database guy. So he
Mm.
builds the areas. He builds the ports, the canals, the waterways, all that's designed by him. And those are our two principal design team members. And then we have our technical support, Jesse Fenton and John Hilliard, and they look after the software and the hardware of the facility. So they're
Mm.
very busy people. They're the guys who are in behind the
Wow.
scenes.
Wow. Okay. What else excites you about the work that you do that you feel like you haven't gotten to touch on yet?
There's always something. For a while there, we had some really interesting events. We decided to use our technology to showcase things from the past.
Oh.
And it was very successful for us, as a matter of fact. We got some no notice out of it.
Mm.
Because not a lot of people know what goes on inside the institute, or even know what's capable here and what the
Yeah.
technology is. And we simulated these maritime events from the past and opened the doors to the public to come in. And as I said, that was a pretty big deal. A few years ago, they had a centenary celebration for Bob Bartlett, Captain Bob Bartlett, who helped
Mm.
Perry get to the pole. He was the captain on the.
Mm.
And anyway, we modeled the ship, the Roosevelt, that they used,
Whoa.
and we worked with Rabbit Town Theater, and they came in and did a drama. Yeah, and people got to come out and go down on the big bridge, and we simulated the voyage in ice, and
Whoa.
that was all interesting. And then that was so successful.
Mm.
Then we moved ahead to the Titanic.
Mhm.
We simulated the Titanic for a documentary that got a lot of acclaim. And then the
Whoa.
biggest thing we did, I think, was we actually replicated an entire convoy from the Second World War,
Whoa.
right down to the U-boat, the corvettes, the U-boats, everything. We let people
No
come
way.
out and see what it was like to be in action in the Battle of the Atlantic
Whoa.
during the Second World War. So that was interesting, and it was
Yeah.
engaging, and it was really well received by the public. So we're actually thinking of maybe dusting
Yeah.
some of that involvement in public events again, because that got to introduce people to the technology that's there.
Yeah.
And, and then just, it was holding up a flag for the Marines too, in terms of what we can do and our involvement in Newfoundland culture and all these great things.
Mm.
In terms of what other interesting stuff, like, yeah, and there's a bit of a story that we also do work on buildings. So we actually use one of the big bridges to simulate buildings moving.
Oh.
Yeah, so the design firm is a specialist in dampening systems that keep buildings from moving too quickly, and they
Mm.
come down with some people, and
Oh.
we designed our building, and we actually put furniture in the bridge, and we hang chandeliers, and they
Oh,
fly
nice.
in with their owners, and they look at, can they feel the building move under different wind speeds? So that's always a bit of interesting stuff. Some of the project work we do is pretty intensive and very interesting. Like the toll outs of the big structures that are offshore. That all goes through our facility.
Well,
It's engaging for the group. They're very demanding, as I say, but it's a team effort. But
sure.
CMS is very much a team effort
Mhm.
as a group. How we approach things, how we tackle really difficult things,
Mhm.
and then give it our best. I think we're looking ahead to how we could support the institute in its applications out in Holyrood at the launch.
Mhm.
What we can do there, we're thinking about maybe ways we can even connect some of our technology to what's out there
Mm.
and be able to do these remote operations. Maybe we can tie in from the launch to CMS and control the simulator or control their ASB from our facility. So
Mm.
those are interesting technical and, um, how should I say, challenge
Mm.
projects that would be very interesting to pursue and would be
Oh.
really a great advantage for the institute to have as part of what it wants to do as the industry changes. And, we're looking ahead to whatever Beta Nord brings to our
Mm.
facility
Right.
in terms of what we will help make sure that people are trained, to safely and efficiently operate.
Mhm. No, absolutely. Can you, for the people that don't keep up with local Newfoundland news, give a little bit of info as to what the Beta Nord project is?
Yeah, so Beta Nord is a new offshore development that is it's in addition to, or not in addition to, but different from the current Jeanne d'Arc operations, which are Hibernia and Hebron, all the existing ones that we know of.
Mhm.
Beta Nord is much further out than the other fields. And, the design phase looks at some sort of floating production, but it'll be the deepest water operation in Canada, deepest
Oh.
well operation in Canada, oil field recovery well.
Mhm.
So there's a lot of obviously very, very intensive engineering demands for how that's actually going to work and
Sure.
what will be. And yeah, so we'll approach that when, they're Equinor, who is the proponent for the field, and they have partners, and we're going to take part in that
Mhm.
when they get to the point of looking at how people are going to be trained for that, then we'll play a part in that
Gotcha.
for Beta Nor.
Sure.
Yeah.
Awesome. Yeah. I mean, me too.
Yeah.
Yeah. All right. I think that's all that I have for you today. Unless there's anything else cool that you think is worth telling our listeners. But
Stay tuned. No,
okay. All right.
stay tuned for some things. But other than that, I really appreciate you taking time to reach out to me. And it's been fun.
Yay, I'm glad. Thank you. I appreciate you coming out here and talking to us all because I learned a lot.
What was your?
I don't know anything about ice. Well, I didn't know anything about ice management before, so this was fun because back where I'm from, we don't have ice. So, except for what comes out of your fridge.
And what's in your drink?
Yeah, exactly. So yeah, thank you so much, Chris, for taking some time out of your day to join me and give us all some more insight into ice management. So I imagine our listeners learned a lot too. And many thanks to all of you listeners out there. This has been Andi with Wavecast, and if you have any stories that you'd like to share with us or others that you want to hear more about, let us know on our social media channels on the Marine Institute's Facebook, X, Instagram, or LinkedIn pages, or reach out to us by email at wavecast@mi.mun.ca. So stay tuned for more episodes of Wavecast and more CMS news, and wherever you find your podcasts. And until then, stay wavy, my friends.